So hello everyone, myself Dr. Pandla Chinna Dastagiri Goud, Assistant Professor from Department of EEE. So BVIT Institute of Technology, Narsapur. So today we are going to discuss about the topic mesh analysis for the principle of electrical and electronics engineering. So coming to the topic, why we'll go for the mesh analysis first. So in the electrical circuits, basically according to our syllabus, we are going to do the circuit analysis for the independent DC sources. That means our circuit consisting of resistors and DC sources, that to independent DC voltage sources and current sources. So for this one, what is the mesh analysis procedure? We followed some steps what we will do for doing this analysis. So first step is we have to identify number of meshes. So in the circuit, how many meshes are available? Then each mesh we will assign a currents like I1, I2, I3 and IN. Suppose n number of meshes are there, it will be from I1 to IN. Then for each mesh we will apply the KVL and we will write the KVL equations to that. After that, from that KVL equations we will use the Ohm's law to express all the voltages in terms of the mesh currents. Right? So because the mesh currents we taken as a variables, that mesh currents we will express by using the Ohm's law. Then we will solve those equations and we will find out the mesh currents. From mesh currents we will analyze the circuit. Suppose we want what is the current, what is the voltage in any element or any circuit parameter. Okay. So we'll go step by step. First we have to understand, we have to identify number of meshes. So first we have to know what is mesh. So mesh is a loop that doesn't contain any other loop or it won't enclose any other loop. What is the meaning of it? So loop means we know that it is a starting point in the circuit. Suppose for example, we'll take a circuit. So this is a circuit we are taking. This has how many elements? So we have passive elements R1, R2, R3, R4, R5, R6. 6 passive elements we have and one active element, that is a voltage source voltage Vs. Suppose we consider this is a circuit and how many nodes? So just I want to mention the nodes. This is A, B, C, D, E and F. So how many nodes we have? Total we have 6 nodes. We can say that node means the elements which are 2 or more elements are connected, that is known as a node. Now if you want a loop, if you say if a loop start at one point and will end at the same point, the path of a current which will start at one point and it will go and it will come to the same point without touching any other nodes twice. Suppose if you take in this one, if you want how many loops we have, so if I will write some loop 1 is equal to A, B, C, D, E, F, A. So the loop 1 is starting from A, B, C, D, E, F, A. It is a loop 1. So now coming to the any other loops we have, so I will write one more loop, loop 2. So what loop 2 we can make? If you see here, A, B, E, F is also a loop. So it will start from A, B, E, F, A. So we are not passing any element twice, so we can consider this one as a loop. So coming to the loop 3. So we can take B, C, D, E, B. This is also a loop. That means, so this is loop 1, this is loop 1, this is loop 2 and this one is loop 3. So total in this circuit we have 3 loops. But if I already told according to the definition, these all are not mesh. Okay, so because mesh means which doesn't enclose any other loop or doesn't contain any other loops. So if you see loop 1, it is enclosing the 2 loops, that is L2 and L3. So L1 is not a mesh. Not a mesh. Whereas L2 and L3, they are not enclosing any other loops. That's why we will consider L2 and L3 as a loops. L2 and L3 as a loops. So there is a difference between the mesh and loop. That means every mesh is a loop, but every loop not a mesh. So first thing in the mesh analysis, the first step we have to do is we have to find out number of meshes in the circuit. So now we understand what is the mesh, how to represent the meshes. So two meshes are there. We'll go to the next step, assigning the mesh currents. So we have to assign the mesh currents. So each mesh, how many meshes are there, that much of currents we have to assign, that much of variables we have to take. So like if you take the previous example, so we have a resistors and one voltage source I taken. So that is Vs. So this is R1, R2, R3, R4 and R5, R6. So we've seen that number of meshes, that is, so this is mesh 1, so I'm taking as M1, and this is mesh 2, this is M2, right? So for these two meshes, we have to assign the currents. So suppose we have n number of meshes, n number of variables will come. Here only two meshes, so we'll consider mesh 1 current is I1, mesh 2 current is I2. But we know that when we are saying the currents along with the magnitude, that means that variables I1, I2, we have to give the direction of that currents also. So you can consider either clockwise direction or anti-clockwise direction. So any direction you can take. There is no particular thing that you have to take only clockwise direction or only have to take the anti-clockwise direction. You can take any direction. You can take both are in clockwise, or otherwise you can take both are in anti-clockwise, or otherwise you can take one is in clockwise, another one is anti-clockwise. The only thing is how the current is flowing. According to that, while writing the equations, we have to take. So thing here is I am taking both are in clockwise direction and the currents are I1 and I2. Suppose I have three meshes. So just I will consider that. Suppose one more element I will add to this circuit. Suppose this will become the R7. Then it will form one more loop. That means one more mesh. So what we will do, that one will become the mesh 3. That one will become the mesh 3. And I will take one more current, that is I3, which is in clockwise direction taken. You can take any direction, but here I am considering the clockwise direction for the examples. Okay. So here if you observe, if you clearly observe how many meshes are there, that much of mesh currents are there, that means that much of variables we are considering. This is our assumption that this much of current is flowing through these meshes and the direction. Maybe the original direction is different, but we are considering it. Okay. While solving the problems, we will understand how we will get the answer. So we'll go to the next step. So now we consider this. So thing is how this mesh currents will consider. So we have to consider the voltages. We have to write the KVL equation. That is the third step I told you. So while writing the KVL equation, what is the definition of KVL? So we'll say that it is the algebraic sum of the voltages. Algebraic sum of the voltages means along with the magnitude, the direction of the voltage, that means plus or minus of the voltage also we have to mention. Then only we have to sum in one mesh or loop. That is the KVL equation. So before going to that, we have to know the sign convention. So we have to follow any one sign convention. So here I am following the sign convention. How the voltages, that means first I am taking the dropping voltages in the circuit. So we are considering only independent sources only in the circuit. So we have only DC sources. So we are considering the elements resistors only in the according to the syllabus. So if one resistor is available, how will you calculate the voltage across that resistor? Because to write the KVL equation, it is the important thing. So if we have a resistor, there is the three conditions available to understand the resistor. Before going to that, we have to consider a point where the reference current is enters, that we will consider as a plus. That means where the reference current is entering into the resistor, that we will consider as a plus. Where it is leaving, that is considered as a minus. Where it is leaving, that is considered as a minus. Suppose if a resistor is in single mesh, the first case I am considering is resistor is in single mesh. What does that mean? If you see the previous circuit, here the R4 is the part of only mesh 2. R4 is the only part of mesh 2. Similarly, R7 is the only part of mesh 3. and R5 is the only part of mesh 2 and R6 is the only part of mesh 1. So if that is the condition, if a resistor is only part of one mesh, what will happen? We'll see that when we are considering this resistor, that mesh current direction. Here reference current I told, that means each mesh current. Suppose the mesh current is flowing from this point, suppose consider this point is A, this point is B. The mesh current is flowing from A to B. So this is the direction of mesh current. So wherever mesh current is entering, that I will consider as a plus. Wherever mesh current is leaving, that is I am considering as a minus. So now we taken this is the plus, this is the minus, and what is the magnitude of this one? So voltage across resistor, if you want, from Ohm's law we know that V is equal to I into R. Here we are finding the VR, so VR is equal to current I1 into R. I1 into R. This is the calculating the voltage and giving the sign convention for a resistor in a single mesh. Second condition. So first condition is resistor in single mesh. Second condition, resistor is between two meshes. Second condition is when resistor is between two meshes. That means, for example, you will see the previous slide, this R2 is between M1 and M2. And similarly, R3 is between M3 and M2. And R1 is between M1 and M3. So these R1, R2, R3 are the meshes, elements which are between two meshes. So if that condition, how we will write the voltage across that element? If you see, suppose this resistor R is in between two meshes, first mesh and second mesh. So that means first mesh current I am considering as I1, second mesh current I am considering as I2. Then what is the voltage across this one? So according to the Ohm's law, we know that V is equal to I into R. We know the resistor value, that is R. What is the current through it? Because it is between the two meshes, it is affected by the two currents, two mesh currents. So one current is flowing in one direction, another current is flowing in another direction. So that time what we have to do, that means both currents are in opposite direction. So if you are referring with respect to I1, that means first mesh current equation you are writing, first mesh equation you are writing, then the I1 is our reference current. So wherever reference current is entering, that we will consider as a positive. Wherever reference current is leaving, that we will consider as a minus. So if you see in this direction, I1 is in this direction, then the current is I1. The current direction of I2 is opposite, that's why it is minus I2. The total current flowing through the resistor is I1 minus I2. So that's why the equation became VR is equal to I1 minus I2 into R. Similarly, for suppose I am considering my reference current is I2. My reference current is I2. That means wherever reference current is entering, that is positive. Wherever reference current is leaving, that is negative. So I2 is my reference current. So I2 is plus. But I1 is opposite to I2. Then it became the I2 minus I1 is the effective current going through this resistor. Maybe sometimes you can ask, so what will happen if both are in same direction? Suppose we will consider we have a resistor R, A, B. Okay. So my reference current is I1 going from flowing through from A to B. And now, so I will consider my reference current wherever is entering, that is positive. My reference current wherever it is leaving, that is negative. Now suppose this resistor is between two meshes, mesh 1 and mesh 2. So mesh 2 current is I2. Mesh 2 current is I2. That is also, that mesh 2 current also flowing from A to B. A to B. Then what will be the effective current? Now the effective current will become I1 plus I2. I1 plus I2. Why means the I2 is same in the direction of reference current. Okay. So this is how we will derive the voltages using the Ohm's law while writing the KVL equations for the mesh analysis. So next step, we will see, suppose if resistors are available, we've seen that how to write the voltages. But suppose current sources are available, how can we say that what is the voltage across a source, current source? Because it is not able to define one ideal current source is available, what is the voltage across it? So the time what will happen, if suppose sources are available, directly we will consider that current value as our mesh current. Suppose current source is available, case 1. If current source is available in a single mesh, suppose I will draw a circuit here to understand this concept. Suppose I have a circuit, simple circuit I will draw. So how many meshes are there in this one? 2 meshes are there. Okay, this is R1, this is R2, this is the value of the current source I, this is the value of the V. So now I am saying it has 2 meshes. So mesh 1 is this one. So I am considering this voltage as I1 as our step 1 is saying and step 2 is saying. So I will consider this is I2 in the clockwise direction I2. Then what will happen? If you see the mesh 2, we are not able to write the KVL equation because of the source available at the as one of element. So what will happen? Directly here you can mention that this I2. So the I2 direction is opposite to source current. So that's why I2 is equal to minus into I. Suppose I already told you instead of clockwise direction I can take the anti-clockwise direction also. If I will consider my I2 as the anti-clockwise direction, then what will happen? Then I2 will become plus. So what is the direction you are taking? That is also important. But one thing, if you observe, if one current source is available in the mesh, that mesh current we no need to calculate, we'll get the value directly. If suppose same mesh is available between the 2 meshes, that is considered as a special case of mesh analysis, that is super mesh. So we will discuss this one in the next video, what is the meaning of super mesh. But the equations will become easy while we are explaining the example. We will see what is the super mesh and how it will work. So we will go to the next step from here. So what is the voltages? So voltages also we have to give, it is a drop in voltage or source voltage or add in voltage. So here if you see, we are going with the convention that if the reference current, whatever the mesh current is going from negative to positive, we'll consider that is a positive voltage. That means current is going in this direction. Suppose consider this is A and this is B. If current is flowing from A to B, and if you see the voltage is minus to plus, okay, so it is the adding voltages. I mean it is not drop voltage, it is source voltage, then it will become positive. And similarly, suppose current is flowing from B to A, then if you see the voltage dropping, that means plus to minus, so I am considering as minus. So what are the sign conventions we taken? If any resistor is there, from plus to minus, it is a minus, right? That means drop in voltage. So I am saying if you considering the KVL equation, we will follow the sign convention that if voltage is going from plus to minus, that is drop in voltage, we will consider as minus of that voltage. If minus to plus, we will consider as a plus, it is a like source voltage. Okay. So now we will write the KVL equation of a mesh. So what is KVL? Already we discussed that algebraic sum of every voltage in the mesh has to be equal to 0. Here each mesh is a loop, so we are considered as a loop. Here the mean is that loop should not enclose with any other loops. So what we will do, we will take one small example so that we can understand this concept well. Okay. So if you consider a small circuit, so I am taking, suppose this is a 20 volts. Okay. Some we'll go with a 10 ohms. Okay. This is 20 ohms. Okay. This is 5 ohms and this one is 15 ohms. Right. So if you see here, so what is our first step? According to our step 1, what is the first thing we have to find out the number of meshes? So first one, number of meshes. Two. And second one, we have to consider currents. So I am taking small currents here. So I1 and I2 as my mesh currents in clockwise direction. So this is my mesh 1. So you can consider anything, either this one as a mesh 1 or this one as a mesh 2, or otherwise this as a mesh 1, this as a mesh 2. There is nothing wrong in that. Okay. So I am considering this is I1 and I2. So in clockwise direction we taken. What is the third step? We have to write KVL of each mesh. KVL of each mesh. So what is the KVL of each mesh? The algebraic sum of every voltage in the mesh has to be equal to 0. So what I am doing, first time we are doing, so I will take each mesh separately. So I will take this mesh. So mesh 1 I am considering here. So what is my mesh 1? Mesh 1 consisting of 3 elements, that is 10 ohms, 20 ohms, and we have a voltage source of 20 volts. Right, this is my mesh 1, and the current in this mesh 1 is I1. So we'll go one by one. What is the resistors? First we have to know, you have to know the voltage of across each element, then only you can write the KVL equation, because algebraic sum of the voltages is equal to 0. So I will consider the voltage across 10 ohms is V1, voltage across 10 ohms is V1, and voltage across 20 ohms is V2. Is that okay? Voltage across 10 ohms is V1 and voltage across 20 ohms is V2, and we have to know the direction of that one. So here you see this is minus, we know that source, so this is plus, and I already told you wherever our reference current is entering, that is this is plus, this is minus, this is plus, this is minus, right? And one more thing here you have to observe, how many 10 ohms is a single loop element, that means only it is belongs to first loop, but 20 ohms is not belongs to only first loop, it is also belongs to second loop, that means second current also affecting. So that current direction also I am taking, that is this is the direction of second current, that is I2. Okay, now we will write the KVL equation. So KVL equation, tell me what is that one? Minus to plus according to our convention, plus, so it will become for mesh 1, so minus to plus it will become 20 plus 20. Here from plus to minus, that is minus V1. Here again from plus to minus, that is minus V2 is equal to 0. Okay, but we are doing the mesh analysis. Our variables are I1 and I2. So that's why I told you in the third step, by using Ohm's law, we have to convert these voltages into in terms of currents, mesh currents, whatever assumed, we assumed I1, I2s. So V1, so what is the V1? So according to the Ohm's law, V1 is equal to I through 10 ohms into R. R means that is 10 ohms. So what is the I through 10 ohms? Only I1. So it will become I1 comma 10. So that means V1 is equal to 10 into I1. So I am writing here, so 20 minus 10 into I1. So coming to the V2, V2 also I through 20 ohms into R. So R is 20 ohms anyhow we know. What is the I through 20 ohms? I already told you we have to find out the effective current through that one. So what is the effective current through that one? So we have to take the direction of I1 with reference to I1. I2 is opposite to I1. So the current will become I1 minus I2. This is the effective current through 20 ohms. Then resistance is equal to 20. So the V2 will become minus 20 into I1 minus I2 is equal to 0. So finally all the variables will keep at one side and the constant is one side. The equation will become 30 I1, here minus 10 I1 minus 20 I1 I bring to this side. So 30 I1 minus 20 I2 is equal to 20. Right? So this is our first mesh equation. Our first mesh equation. Coming to mesh 2. Coming to mesh 2. So I am writing a mesh 2 equation also separately. Mesh 2 I am drawing here. What is the mesh 2 consisting of 5 ohms and 15 ohms, 20 ohms. You don't have any sources, right? Okay, no problem. Okay, and what is the current direction? We taken as a clockwise direction, and that too the current is I2. The current is I2. So wherever current is entering, I told you wherever current is entering, that is reference current plus minus plus minus, plus, minus. Now we'll see what is the voltages across this one. So this one is voltage across this one is I am considering as V20 because V20 ohms, V5 ohms, and this is V15 ohms. V15 ohms. Okay. So now what we have to do, we have to apply first KVL. So KVL, if you apply from here to, we'll start from any one point. So I will start from V20, this point I will start. So what will happen? The current direction is this one. So plus to minus. So plus to minus means voltage is dropping. That means minus V20 ohms. Here also voltage is dropping. Plus to minus current is going. So minus V5 ohms. Voltage is dropping again resistor. So plus minus V15 ohms is equal to 0. So if you take all minus ones, it will come V20 ohms plus V5 ohms plus V15 ohms is equal to 0. Now we have to convert this equation into the mesh equations by using Ohm's law. So according to the Ohm's law, what is V5 ohms? So 5 ohms is only in the mesh 2. 5 ohms is only in the mesh 2. So that what will happen if it is in only mesh 2, the current through this one is only I2. So the current is I2 and the resistance is 5 ohms. It will become 5I2. So V5 ohms will become 5I2. So this is plus, so it will be in plus. So coming to the V15 ohms. This is also, if you observe the circuit, the V15 ohms is only belongs to mesh 2. So the current is I2. So current is I2 and the resistance is 15 ohms. It will become 15I2. It will become 15I2. So V15 ohm is equal to 15I2. But coming to 20 ohms, it belongs to two meshes. Belongs to mesh current 1, mesh current 2. So that's why we have to see what is the effective current. So here that means this 20 ohms, another current is outside, which is opposite to the I2, that is in the direction of opposite to I2, this is I1. So the effective current is I2 minus I1. Therefore V20 ohms is equal to I2 minus I1 and the resistance is 20 ohms. So finally V20 ohms became 20 I2 minus I1 is equal to 0. So if finally if you see, if you make all the variables, so 20 I2, 5 I2, 15 I2, it totally became 40 I2. And what is the I1? Minus 20 I1. So I am writing in the ascending order. So first I1, then I2. So is equal to 0. This is my mesh equation 2. This is the way to write the mesh equations. Right? So once mesh equations is available, then we have to solve the equation. Suppose we will solve the same problem equations. What is from these two meshes we got? First one is 30 I1 minus 20 I2 is equal to 20. So 30 I1 minus 20 I2 is equal to 20. This is from the mesh 1. And next one is, it came minus 20 I1 plus 40 I2 is equal to 0. So second equation is minus 20 I1 plus 40 I2 is equal to 0, which is mesh 2. So you have to solve these equations. So we have so many methods. So by using the calculator you can use. So in calculator, in the equation mode, if you go and you can solve these two problems. So either you can do for the cancellation, so you can multiply with this one. So I am going with the calculation mode. So we have two variables. So we'll go for the two variables. Okay. So we have 30 I1 minus 20 I2 is equal to 20, and then we have minus 20 I1 plus 40 I2 is equal to 0. It is a two variable problem, so you can do directly by the mathematical cancellation. But if you meshes are more, if it is 3 or 4, better you go for the calculator. So what we got I1 is equal to, so after solving the equations we'll get I1 is equal to 1 ampere. I1 is equal to 1 ampere and I2 is equal to 0.5 ampere. I2 is equal to 0.5 amp. So what exactly we got? I1, I2 values we got. That means we got the mesh currents. So what is that mesh currents? If you see here in the circuit, you got mesh current one, I1 is equal to 1 ampere, I2 is equal to 0.5 ampere. It doesn't mean that is the current through each and every element. Here the main thing we done analysis. So what is the question they ask? What is the current through 10 ohms, or what is the voltage across 10 ohms? That is the questions they will ask. How to solve those things, just we will see. So I will draw the circuit here once again to understanding purpose. After the doing analysis, what is the values we'll get. Okay. So we have a simple circuit for the analysis we made. Right. So in that circuit we have only this much of resistors. So we given 20 volts input DC, and this is the 10 ohms, and this is 5 ohms, this is 15 ohms, and whereas this one is 20 ohms. Now you got by mesh analysis, this mesh current I1 is equal to 1 ampere, I2 is equal to 0.5 amperes. So what does that mean? What is that mean? So they are saying that I1 is equal to 0.5. That means in 10 ohms it is going the I1 current only. So from here it is going 1 ampere. So we know that I1 is equal to 1 ampere, I told. So it is giving 1 ampere current is going through this one. And I2 is equal to how much? 0.5 amperes we got. That means 0.5 amperes is the direction. So same current it will go here. Then what is the current through this 20 ohms? So by observation we can say, if you apply the KCL, this is 1 ampere is coming, 0.5 amperes is going this direction, and this is the 0.5 amperes easily we can say. But the mesh analysis, how we'll consider. So if you see, so if you want to find out V10, we know that I1. If you want to find out current through 5 ohms, that is I2, 0.5 amperes, 15 ohms, 0.5 amperes. The only problem will come, what is the current through 20 ohms? So because in mesh 1 we taken as I1 minus I2, and mesh 2 we considered as I2 minus I1. So which one is correct? There is most of the students will do the problem on mistake on this. So if you consider, what is the I1 we got? 1 ampere, and what is the I2 we got? 0.5 ampere. So the answer coming is 0.5 amperes. If whoever is want to go with the mesh 1. Mesh 2, sir, no sir, I want to go with the mesh 2. So what is the answer? I2 is 0.5 amperes minus I1 is 1 ampere. So how much answer we are getting? 0.5, but with the sign of minus. It means both the times you got the magnitude same. If you do this magnitude will same, here direction is different. So if you consider I1 minus I2 got positive, that means I1 is bigger one. So whatever the direction you are considering, it will be in the direction of I1. But when you do I2 minus I1, you got minus. That means it is not opposite to the direction of I2. That means it is from up to down. So whatever you will do, both the answers are same, but you have to mention what is the direction of that current. So here we have to take care while solving this equations using the mesh analysis. So we will see the next lecture on this super mesh analysis. What I told, if current sources are available in the circuit, how we have to solve them in a mesh analysis. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.